This is a completely custom chatbot that I built to help my retired dad learn a piece of music software called FL Studio. It's something called a RAG. Now, a RAG is a process for optimizing LLM responses that combine a retriever model capable of searching a knowledge store with a large language model to provide generally more accurate and up to date answers than a typical LLM. RAG stands for Retrieval Augmented Generation. And in this video, I'm going to be showing you how to build your own custom chatbot just like this one. And we're going to be doing it in Databricks completely for free. Are you ready? Hi, my name's Ned, and I normally make videos about a subject called business intelligence, which does involve working with data. I know SQL and I know Python, but I don't have a background in data science. And earlier this week, I decided I wanted to try and build an AI of my own. So, like anyone who's learning something new these days, I turned to AI and asked it, how do I customize my own LLM? And what I learned is there's really kind of three different ways that you can customize your LLM. The first and the most easy is you can provide context with your prompt. So this would be the equivalent of saying in your prompt, hey, my name's Ned, asking a question, and then asking it later on, hey, what's my name? It'll probably respond with Ned. This is great, but you haven't done anything to fundamentally change the model. So the next time you log back in, the chatbot might not know your name because it might not have that exact same concept. The next kind of step up from just providing context with your prompt is something called fine tuning. Now, fine tuning is a technique where you take a pre-trained model, like for example, you would take ChatGPT or you would take DeepSeek, and you adapt it to a more specific task. It's a way to transfer learning, especially when you don't have the resources to train a model all the way up. And that then kind of brings us to our third and most resource intensive, which is building a custom model of your own. Now, each one of these exponentially requires not only an increasing amount of knowledge of data science, but also an increasing amount of compute. So, as you can see right here, right, providing context with your prompt is simple, anyone can do it, but building a custom model requires a ton of domain specific knowledge around data science. Now, I not only do not have the knowledge required to fine tune a model or to build out a custom one, but I also don't have any compute to retrain or to fully train up a model. That kind of computer hardware is expensive and it's something that I don't have. Now, all this left me pretty down in the dumps because I thought there was, well, nothing I could do. But then I stumbled upon the concept of a RAG. So, what is a RAG? Well, a RAG is really more of an AI system rather than an individual model. It consists of both a retriever and a generator. And the generator in our case is an LLM. And in the one that we're going to be building today, that retriever is going to be executing queries against something called a vector store, although it could be anything, any kind of knowledge source. The way it works is when the user sends the bot a query, that query flows to the retriever. That retriever executes the query against the knowledge store, which then provides context. And then that query and context is provided to the LLM, which then uses it to answer questions back to the user. Now, this was something that I could work with. You see, Databricks, who self describes as the data and AI company, has already released a ton of tutorials on how to build a RAG on their platform. Not only that, they've also released a completely free version of their software. So now I had a step by step guide telling me how to build out my custom AI chatbot, and I had the software and the infrastructure to do so. So, just like that, let's get started. We're going to be following Databricks' tutorial and we're going to be building a RAG of our own. All right, so it's the next day and I'm ready to get building. So, the first thing that you need to do is you need to get a Databricks free account. Now, I'll link a video down below in the video description on how you can sign up to get a Databricks free account. But for the most part, you can just Google Databricks free and sign up. Now, our first task that we have in front of us is we need to build out our knowledge store. Now, the way that we're going to build out our knowledge store, and just a reminder, the knowledge store is what's actually being queried, is we are going to create what's called a vector search index. But before we can do that, we need to actually build a table of information. We can build that table of information through a process called chunking. Chunking is essentially where you take a large piece of data, like for example, a PDF on how to use FL Studio in my example, and you break it down into smaller pieces. So the first thing that we're going to need to do is we're going to need to go into catalog. For the purposes of this tutorial, I'm going to go create catalog, and I'm going to name this catalog rag demo. And it's going to not want me to put spaces in it. All right, so I'll go rag underscore demo and I'll hit create. Once that is up and running, we're then going to have two different schemas, right? And that's the first schema is going to be default, and then the next schema is going to be information schema. For the purposes of this demo, I'm going to use the default schema, and I'm going to create a volume. Now, you can think of a volume kind of like a folder on your computer, and it's where we're going to upload PDFs, because in this example, we're building our knowledge store with PDFs. Partly because I don't know how else to do otherwise, because the basic Databricks tutorial didn't show you how to do that. Just, level saying my information here. But I'm going to call this volume documents. I'm going to go ahead and I'm going to hit create. Now, once we have this documents folder, we're going to want to upload the PDFs that we want the LLM to be able to access. So these are the PDFs that we're going to run through some Python code and chunk into individual small pieces. Now, on my desktop here, I have a video right here called Image FL Studio, and this is the user manual. So I'm going to select this, and then I'm going to go into upload. Now, Databricks in their tutorial, which by the way, I'll link their tutorial down below in the video description in case you would rather just read instead of watching me ramble, used some PDF chunking software or code that was pretty hefty because it was designed to be a pipeline. So as you added new files, it would just chunk the new files instead of starting from scratch. This was a little bit too complex for me. I just wanted something where it's like, hey, every single time you delete the knowledge store and you recreate it from the ground up. So here is the code that I pretty much vibe coded my way into. But it's pretty simple stuff. The first thing that we're doing is we're installing Python modules. Now, Python modules are reusable pieces of code that other people have written that you can use in your own code. The two that I'm installing are PyPDF and then transformers. And then because I am in a notebook, when I install a module, I need to restart Python in that notebook. So I'm going to go ahead and run that. And while that's running, I'm going to move down a bit here. So I'm importing OS, which is how we'll access files across the Databricks system, and then importing that PDF. I'm importing list and dictionary, which is how I am going to essentially split some of this PDF. An auto tokenizer, which is how we're going to make sure that the chunks that we're creating are not too big. And then I'm importing a module here that will allow me to interact with the Databricks service. The next kind of step that I'm doing here is I am defining the table that I want it to create my PDF chunks for the knowledge store in. So in this case, I have it set to workspace.dev. Remember, I created a schema over here called rag demo. So I'm going to go over here and I'm going to go rag demo. And then instead of dev, I'm going to go and I want this to be put into default. All right here, right? Because that's the name of my schema. And then I think the table name is okay here with FL Studio. The volume path is going to be my volume. Now, a quick little Databricks hint right here. You can delete this and you can go over right here and you can go insert volume name and it'll insert in that volume name. The tokenizer model, so the model that I'm going to be using to kind of go through and split this, is going to be Facebook's open source model. And then the max amount of tokens that I'm going to use to chunk my data is going to be 500 tokens. Now, when you chunk data, ideally you want to chunk it where it naturally splits, right? So by naturally split, I mean at a end of a sentence or the end of a paragraph. That will produce kind of the RAG system that gives you the best results. So these \NN is wherever there's a double like new line. \N is wherever there's a new line. This is wherever there's a space, and then this is where there's not a space. And our code is going to move through these in preference as it starts to chunk it down, and it's going to try to keep the biggest chunk of text together under 500 tokens. I've then defined right here a method that goes through and it loops through all of the PDFs in our path, and it reads that PDF into text. This is kind of a helper method. And then finally, we have our chunk text method, and this is what's actually doing the chunking. So it's getting sent text, and it's saying, hey, for every single separator in our separator array right here, start to chunk. And so the first thing it will do is it'll check and see if the length of the chunk is more than the max tokens per chunk. And if it is, it will split it again. And it'll keep on kind of doing this loop over and over and over and over and over again until we get appropriately sized chunks. Finally, for each PDF, we'll have an array of PDF chunks, and it will start to encode them using the model up above, and then it will return an array of all of the encoded chunks. Here is a method that processes and inserts those chunks into the PDF, right? And so it gets the text from the PDF, right? It calls the chunking method, and then it tries to insert them into a Spark table, right? So that's where this Spark table. And side note, Databricks is a data lake software. It is based on Spark. So when I say insert into a Spark table, it is inserting into a table in its path. And then here's the main method that's executing it all, right? So that main method, or it's not even a method, it's a main execution block. But here's the code that's like kind of synchronizing it all. The first thing that's trying to do is it's trying to describe the Spark table that I want to create. If it can't find it, so if it's getting an error, it's then creating the table, right? If it does find the table, it's truncating it. So that means it's deleting all of the data out of it, and it's setting the table name to whatever I set up above. And then it's also making sure that it's a delta table. Both in this scenario, we need this to be a delta table. In this video, I'm not going to cover what that is, but the vector store needs that. And then for each file, it's going through and it's processing and inserting those chunks into that PDF. Now, this was a large code review. I'll link this code down below in the video description. So that way, if you skipped all the way through this, or if you're trying to pause the video to write the code, you don't have to do that. It's just available for you to download. Cool. So let's go ahead and let's run this and let's see what we get. So there's a bunch of text down here. We got a warning, but it looks like it chunked our data into 119 chunks. So let's go over to the same schema that we are in. So I'm going to expand that catalog and then go into default. And what we should now have is a table. And we do have a table. And if you notice, here it is. It's this FL Studio chunks. So I'm going to go over here to these three dots, and then I'm going to go open in Catalog Explorer. Now, once we're in Catalog Explorer, we can see our table, and we've got two columns. We have a primary ID column, and then we have a chunk column. I'm going to go ahead and click sample data right here, and then select compute and start our serverless warehouse. Now, while that's starting, we need to actually create some other compute. And that other compute is going to be a vector search compute. Now, I've already created a compute right here. And I think with Databricks Free, you can only have one vector search endpoint, but we're going to try to create one anyway. So I'm going to name this FL Studio, and I'm going to leave this as a smaller one. And I'm not going to have a budget policy, right? And there we go. We can only have one vector search index, but that's how you create one. I'm not going to delete this one that I've already built. So I'm just going to leave it as test. Going back then into Catalog Explorer, so going over here into the catalog, going into RAG demo, going into default, and going into tables, then going into FL Studio, it's now time for us to create what's called our vector search index. Now, this is what our retriever in this model is actually going to be using to get data. So I'm going to go back over here. I'm going to go down to these three dots or over here to create, and then I'm going to hit vector search index. Now we're going to need to create a vector search index name. So in this case, I'm going to go vector studio, and I'm going to name it _idx. My primary key is going to be my ID. I'm going to leave this blank. My compute embedding, so the column that I want it to embed is going to be chunk text. My embedding model is going to be the Databricks GTE large. Okay. And then my vector endpoint is going to be my test. Now, this is where I'm leaving this as triggered, but you could have this continually look for new information, which is what continuous would be. And I'm going to go ahead and I'm going to hit create. Now, this is going to load, and this is going to start to provision our index. Now, this index status is going to give us a ready when it's ready for us to use, and then we always want our endpoint to be ready right here. If we go ahead and we do add new data into our underlying table, because this isn't a continuously integrating index, we will have to go over here and we'll have to tell it to do a sync. So at this point, we now have our knowledge store pretty much ready for us to go. So it's time for us to start to build out the retriever and then hook that in with a generator. Now let's get into our new code so we can figure out how we did that. Now, I want to say that by the time I generated this index, I was feeling pretty good. So I went off and I tried to not follow the Databricks tutorial. And in that, I learned a fair amount about the way this is working. The biggest thing that I learned is that when we're using MLflow to deploy a model, MLflow has to be able to serialize kind of that model itself. And in order for it to serialize, we have to save the Python code uh, off into its own folder. I was stuck on that. It took me like 90 plus tries of trying to build this model before I realized that I needed to save the Python code over. So with that said, I'm going to show you how we ended up initially building this. So again, over here, the first thing that I'm doing is I am importing some modules. I'll run that while we're waiting, and then we'll kind of move through the other settings. The first piece that we need to do here is we need to set some kind of base models that we want it to use, or base variables that we want it to use. The first of which is being the actual LLM that we're going to be interacting with. In this case, I think you actually sometimes want a smaller LLM because that way it is less likely to hallucinate. Although I could be wrong again on that, but anyway, this is the Databricks one that we're using. We're going to feed it our vector search endpoint compute's name. So in this case, mine is named test. We're going to feed it our catalog. Mine is no longer workspace. It's now called rag demo. So I'll title this rag underscore demo. My database is going to be my default. And then my vector search index right here. If we go over and we look at it under tables, is FL Studio index. So I'll go ahead and I will trim this. Let's move down to this code. And this code is kind of broken into smaller pieces, and it still has some prompts from when I ran it yesterday. So I'll use that to kind of talk through this. All right, the first thing that we're doing here is we're checking the we're building out like our retriever, and we're checking that retriever's ability to pull chunks for us. And we're saying that we want the retriever to return 3 chunks. So the 3 chunks that match our question the best. In this case, right, we're invoking our retriever with the question, what is FL Studio? And as you can see, it pulled a bunch of different chunks back for us right here. So you can see here's a passage, and then here's a passage. So you can see it pulled those 3 chunks back for our LLM. The next thing that we're doing is we are actually now starting to introduce some prompting with our chat model, right? So in this case, we now should get a response back from the chat model, right? So we're saying, hey, chat prompt template, and we're using the LLM prompt template, which, by the way, the LLM prompt template is the initial instructions that I gave it. So I said, hey, you are a chatbot meant to help my retired father, Jeff, learn some software. Some pieces of content that you're going to be getting from the vector search might be irrelevant, in which case ignore them. If you do not know the answer, just say, I don't know, and then I provide it with that context. So going back down, what over here you'll see is we are now using that LLM prompt plus the question, and we're giving that to Databricks, which means it's getting the prompt, the context, right? Because here's the context it's providing, as well as the question. And then we're configuring the model a little bit, and we're now answering or asking it another question. We're saying, hey, how should you create a new project? And as you can see, the answer that we're now getting looks a lot more like an LLM response. Now, the next piece of this that's probably one of the more important pieces is we need to actually construct our RAG chain. Now, the RAG chain is what coordinates everything that we just showed you up above. So retrieving data using the vector index, and then feeding it back into the LLM along with the question. So it's getting the question and the context all in one single fluid thing. And so that's what this code right here is doing. I'm going to go ahead and I'm going to hit run, and this is going to generate our chain. So now, instead of having to have all of this code up above, right, what we can do instead is we can take our input example, we can feed it a answer, and that can be chain invoke input example, and then we can print our answer. So when we run this, what you'll see is it will generate out that same exact answer, similar to the way an LLM would, only this time we're now using this chain that we created up here. Moving then down, we do need to write some files locally. So the first file that we're going to write locally is going to be our chain config that we just kind of created up here into what's called a YAML file. So I'm going to run this code, and that's going to go ahead and that's going to generate this file right here. And this set has all of that information that we just kind of populated up above in the very first cell of this notebook up here. The next file that we're going to create is going to be the actual Python mod file that kind of contains all of this put together into a single script. And this file we're going to have to write locally. That way MLflow, which is what we're going to be using to deploy this model, can actually serialize it. And as you can see, it's going to be referencing that chain rag chain config YAML that we just created. So I'm going to go ahead and I'm going to run this. Now, once this is run, we then are ready to register our model with MLflow. Now, when we register our model with MLflow, and if you notice I was searching for signature there, we have to define a signature, and that signature is going to be our input example and then our answer. And then we have to give it the chain, right? Or which is going to be that model right here. So when we run this, and then one other thing you just need to update is you need to update the run name, and then you need to update the model name that you want it to register. So I'll run this quickly, and you'll see a bunch of text flow across the screen, but it will eventually register this model over here in this models section of Databricks. And we'll take a look at that in a second. But before we do that, we just need to take that model and we need to register it, and we need to deploy it. Out via like a serving endpoint. So that's what we're going to be doing right here. And we're going to be using Databricks agents. So I'll go ahead and I'll click a run. Now, just a heads up, if you are on a Databricks free account, you can have up to 2 serving endpoints, but only one of them can be running at a given time. So if you're running into timeout errors, that's typically what's going on. And that will eventually give us, right, our model fully deployed out via a serving endpoint, right? And so here we are in our review app. And then here we are, we can check the actual status of that model that's being served. And as you can see, it's actually not ready, so we can't chat with it at the moment. Going back into models over here, we can see the various models that we've registered, and you can see like I've registered quite a few, right? But the one that we just registered was this DAD FL Studio Chatbot video demo. So let's let this serving compute turn on and deploy, and then let's take a look, and hopefully everything is up and running. Okay, so here we are and it's ready to use. So the first thing I'm going to ask it is, my dad is not a good singer. How can I auto tune? And let's see what it says. So without me providing any context, I was talking about FL Studio. As you can see, it defaulted right to providing you how to auto tune in FL Studio, and it's providing very specific directions. So there you have it. That's how you can build your own custom AI chatbot from scratch. Now, one quick note, this bot is not sophisticated enough to take into account the prior chat history. So if you're interested in a video on how to do that, let me know down in the video comments and I'll consider making it in the future. I'll link all the code that I was using and running throughout this video on my GitHub down in the video description, as well as the original Databricks tutorial that kind of got me started down this rabbit hole. And with that, if you enjoyed this video, please subscribe and give it a thumbs up. Thanks for watching.